In class example 1.41, we will apply 4 transformations to a given graph. Here, we'll take y equals f of x and transform it into g of x, which is defined as 1/2 of f times negative x plus 2 plus 1. The question first asks us to construct a mapping rule. And even if it hadn't, this is a great way to approach this question. Transforming a graph with 4 separate transformations one at a time can be a little bit cumbersome and often leads to small errors. Let's see how the mapping rule will help us. First, we want to prep our function by factoring out that b value. Because we had a negative in front of the x, we'll take out -1 from the bracket, which will change it to negative times x minus 2. This means we have a vertical stretch by 1/2, a reflection in the y-axis, a shift of 2 to the right, and 1 up. In mapping notation, we'll represent this by showing that our x value became negative and was increased by 2, while our y value was multiplied by 1/2 and increased by 1. This mapping notation allows us to take any point and substitute it in place of x and y and determine the coordinates of its transformed point. So, if we take -7 and multiply by -1 and then add 2, and if we take -5, multiply it by 1/2 and add 1, we find that our transformed point would be 9 and -1.5. This is easier than drawing the same graph 4 times after each transformation. Now that we have transformed all of our points, we can sketch the graph. Next, we're told that the point P, whose coordinates are 0 and 2, lies on the graph of f of x. In order to find its coordinates on the graph of g of x, we will use the exact same process, substituting into our mapping notation. Here we determine that the point 0 and 2 transforms to 2 and 2. Given that we've already drawn the graph, we can identify that the domain of the transformed graph is from the leftmost point of -7 to the rightmost point of 9. And the range is from the lowest point of -1.5 to the highest point of 3.